Data from the James Webb Space Telescope has shown that an exoplanet around a star in the constellation Leo has some of the chemical markers that on Earth are associated with living organisms. But these are vague indications. So, how likely is it that the exoplanet harbors alien life? Come with me and find out. Hey guys, welcome back to my channel. And as I was telling you, there are possible hints of life found on a distant planet called K218b. So, the exoplanets are worlds that orbit stars other than the sun, if you didn't know about that. It's so named like K218b because it's the first planet to found to orbit the red dwarf star, which is K218. So it's named K218b. There is a K218c as well, the second planet to be discovered. The star is dimmer and cooler than the sun, meaning to get same level of light as we do on our Earth, the planet would need to be much closer to its star. The system is roughly 124 light years away, which is very far away, but is quite close in astronomical terms. So, what are conditions like on this exoplanet? This is quite a difficult question. We have telescopes and techniques powerful enough to tell us what the star is like and how far away it is, but we still can't capture direct images of the planet. We can work out a few basics, however. Working out how much light hits K218b is very important for seeing that if the planet has potential for life. K218b orbits closer to its star than Earth does. It's roughly 16% of the distance from Earth to the Sun. Another measurement we need is the star's power output, the amount of energy it gives every second. K218's power output is like only 2.3% of that of sun. Using geometry, we can work out that K218b receives about 1.22 kilowatts in solar power per square meter. This is quite similar to 1.36 kilowatt of incoming light we receive on Earth. Although there's less energy coming from K218, so it evens out because the planet's closer. So far, so good. However, the incoming light calculation doesn't take into account clouds or the how reflective the planet's surface is. When we consider life on other planets, a popular term to use is habitable zone, which means that an average surface temperature water will be in liquid state, as this condition is considered essential for life. So, like the planet has to be in a habitable zone, otherwise, it's the planet's just too hot or just too cold. And it also depends on the planet's clouds and how reflective it is, as I told you. In 2019, a few years ago, the Hubble Space Telescope determined that K218b showed signs of water vapor, which is good, suggesting that liquid water could be present on the surface. It is currently thought that there are large oceans on the planet, but we don't know this. But then this caused a ripple of excitement at the time, but without further evidence, it was just an interesting result. Now we have reports that JWST, the James Webb Space Telescope, has identified carbon dioxide, methane, and possibly the compound dimethyl sulfide in the atmosphere. The tentative detection of DMS is significant because it is only produced on Earth by algae. We currently know of no way it can be naturally produced without a life form. So maybe a life form exists, but we certainly do not know. So, is there life on K218b? All these indications seem to suggest that K218b might be a place to go find alien life, but it's not quite as simple as that, though, as we have no idea how accurate these results are. The method used to determine what is the atmosphere of an exoplanet involves light from a different source, usually a star or galaxy, passing the edge of the atmosphere, which then observed by us. Any chemical compounds will absorb light in specific wavelengths which can be identified. Imagine you're looking at a light bulb through a glass tumbler. You can see through it perfectly when empty. If you fill it with water, you can still see through pretty well, but there are some optical effects and coloration, which are the equivalent of hydrogen and dust clouds in space. Now imagine you poured in red food dye. This might be the equivalent of the main chemical constituent in a planet's atmosphere. The most atmospheres are made up of many chemicals. The equivalent of looking for any one of them would be like pouring 50, like many more colored food dyes, as I told you in the tumbler, in different amounts into your tumbler, and trying to identify how much of one particular color is present. It's very difficult with task with plenty of room for subjective assessment and errors. In addition, the light going through atmosphere contains a signal of the star's chemical constituents, further complicating the analysis, which it's just very hard, guys. Only a few years ago, there was a surge of interest in whether life existed on Venus, as observations had indicated the presence of phosphine gas, which can be produced by microbes. However, this finding was later successfully refuted by several studies. So, if there can be confusion about what in the sort of a planet is, that's just next door. In astronomical terms, it's easy to see why analyzing a planet that's many times further away is a very difficult task. So, the chances of life on exoplanet K to 18b are low, but not impossible. Results will likely not change anybody's opinions or beliefs about extraterrestrial life. Instead, they do demonstrate the advancing ability to look into worlds that are not owned and find information. The power of James Webb Space Telescope is not only in producing incredible pictures but in providing more detailed and accurate data on celestial objects. Knowing which exoplanets host water and which do not could provide information on how the Earth was formed. Studying the atmosphere of a gas giant, exoplanets can inform the study of similar worlds in the solar system, such as Jupiter and Saturn, and identifying the level of CO2 indicates how an extreme greenhouse effect might affect a planet. This video has been too long, so bye. I hope you liked this video. If you did like this video, please like it and subscribe, and bye.